Hello, everyone, and welcome back to another Planetarium stream. My name is Jessica. I'm the director of the Planetarium, and with me tonight are two of the students who work in the Planetarium, and I will let them introduce themselves. We'll start with Eli.
Hi, I'm Eli. I'm a physics and astronomy undergraduate student at UMD.
Hi, I'm Lindsay. I'm a physics graduate student at UMD.
So, tonight we are going to be taking a look at what it takes to get into space and all of the awesome things that SpaceX and NASA have been doing over the past year. And Eli is going to be the one telling us all about that tonight. So, as always, if you have any questions throughout the show tonight, leave them down in the comments. I will be keeping an eye on those, and we'll let Eli know as questions come up. There will also be time at the end for those as well. So, with that, Eli, take it away.
Alrighty, let me know if this looks okay, because I know it always takes a little bit of messing around to get the window looking right. So, does that look good?
I think so. Yeah.
Oh, cool. Alrighty, so traveling to space. First, we'll talk about kind of what goes into selecting and preparing an astronaut. Then take a look at what astronauts do once they are in space, namely in the International Space Station, since that's kind of the main location for astronauts these days. And then after that, talk about some of the things SpaceX has been up to and is up to recently. So the first thing I want to talk about is the kind of training that astronauts undergo. Astronauts go through extremely rigorous and trying training to be qualified to go to outer space. And it really goes above and beyond what you might think. Even before being considered for being an astronaut, astronauts have to meet extremely and like almost weirdly specific requirements. First and foremost, to be hired by NASA as an astronaut, one must be a citizen of the United States of America. Aside from this, the individual must have a master's degree in a set of STEM fields such as biological sciences, physics, engineering, mathematics, things like that. And then after that master's degree, the individual must have either 2 years of professional experience in their field, which can be like substituted by progress in like a PhD or something like that, or 1,000 hours experience as a pilot in command in jet aircraft. Additionally, astronauts have to exhibit certain physical features, including but not limited to adequate eyesight that is correctable to 20/20 with glasses or contact lenses, a heart rate below 140/90 while sitting, and a height between 5 feet 2 inches and 6 feet 3 inches. In order to apply, they also have to take like a prerequisite exam that can be up to 2 hours. After their acceptance, astronauts spend up to 2 years training for the conditions they'll face in outer space. And that includes taking numerous classes on physics, medicine, first aid, survival, language, which is more often than not Russian, to communicate with Russian cosmonauts on the International Space Station, and public speaking. They also spend a lot of time learning the ins and outs of the craft they'll be traveling in, and they interact with scale replicas on a daily basis, as well as undergo underwater training to simulate microgravity. They also go aboard what is lovingly called the Vomit Comet by experienced astronauts, which is a specialized aircraft that offers about 20 seconds of weightlessness during a flight. So seen here is what's called the Neutral Buoyancy Laboratory, and it's a 40-foot deep pool used to practice weightlessness and like the execution of weightless activities that would take place outside of the station. And they can spend up to 7 or 8 hours training in there, which is the length of an average spacewalk. So next, I want to show a video of this idea of a vomit comet. Just like this zero-G microgravity experience and like training. So First off, I think the music in that video is really fun. I kind of like that. Also, that looks really fun, but as it said, it kind of carries a hefty price tag. It is commercially available, and people can just do that. An image that sticks out in my head is physicist Stephen Hawking going on one of those planes. I don't know how well I would do, and I think it has the name Vomit Comet for a reason. The only thing I can think about when I hear that name is how that vomit might behave in zero gravity, and that scares me. So I think I will probably avoid going on that myself, as if the price tag weren't an obstacle. But that's just one component of the training that those astronauts do. Like I said, other things include those classes, those underwater like training exercises. It really puts them through the whole 9 yards. There's also like a roll cage apparatus that the astronauts strap into that just like rolls around and like disorients them for extended periods of time. It's really jarring, and I think it probably takes the best of the best to be able to do that. Um, so as for spacesuits, which is another really interesting part of it, astronauts have to wear spacesuits in certain environments to protect them from the conditions of outer space, and will sometimes wear them even when in the spacecraft for protection, in the event of a malfunction or a failure of the craft to protect them. There are many different types of spacesuits designed for many different purposes. The spacesuit on the left is NASA's Extravehicular Mobility Unit, which is shortened to EMU. Spacesuit designed to protect astronauts from the conditions of pure vacuum as they would experience during spacewalks. These suits offer life support functions such as oxygen supply, as well as a communication system, protection from radiation, pressurization to combat the vacuum of space, and temperature control. The suit is actually composed of three separate layers. The first being the maximum absorbency garment, which is fancy in NASA terms for an adult diaper. After that, there is the thermal control undergarment, again, fancy terms for long johns. And after that, the astronaut dons the liquid cooling and ventilation garment, which is what you're seeing there, which is a bodysuit with tubes running inside of it, some with chilled water for temperature control and some for waste gas removal. And then the outer layer of that suit on the left is called the pressure suit, and that's they put on and lock the helmet in and they pressurize it so you don't get crushed by space, or the opposite of that, I suppose. And then the astronaut enters a depressurization, and that's a hard word to pronounce, depressurization chamber to ensure the suit is locked and ready for vacuum. Um, Now, what I think is really cool on the right is SpaceX's Starman spacesuit. This was designed in collaboration between Elon Musk and Jose Fernandez, who's a costume designer in Hollywood, and he's done movies such as The Avengers and Tron. I mean, it totally does look kind of Tron, Daft Punky. And it was reverse engineered by SpaceX and offers astronauts vacuum protection and basic life support, but it's not suitable for extravehicular activities because there's no protection against radiation, which is also something you have to think about in the vacuum of space. But I love that spacesuit. That's really cool. It looks like it came right out of a sci-fi movie. Um, so, oopsie, my slide isn't going over. There we go. So the next challenge is actually getting the astronauts, or in other cases, satellites and telescopes into space. A 16-gallon tank of like gas for your car contains enough energy or expendable energy to get an astronaut into low Earth orbit, which is kind of a shocking fact to me. So like the tank of your car probably plus a few gallons is enough to get me into space right now. The only problem is that the astronaut needs a rocket to burn that fuel and use that energy, and rockets are much heavier than people. So you need more gasoline then to propel the rocket. And the problem is that it's kind of like a stacking problem because by now you've added more gas to fuel the rocket, which means that you need a bigger rocket to produce more thrust and burn that gas. And then since you need a bigger rocket, you need more gasoline, and it quickly becomes kind of a stacking issue and a large instrument. Um, Luckily, we don't use like car gasoline to fuel rockets anymore, and we have much more efficient fuels such as liquid hydrogen, which is lighter and provides more thrust. But even still, rockets need to be massive to lift modern payloads into space. And seen below, on the left, is SpaceX's Falcon 9 rocket and Crew Dragon, the capsule that houses the astronauts until they dock at the International Space Station that's been being used recently. The Crew Dragon capsule seen on the right, fits in the white nose cone at the top of the Falcon 9 rocket, and the rest of the rocket is dedicated to fuel storage and combustion. So there's simultaneously not a lot that goes into a rocket and way more than I could ever understand that goes into a rocket. But the main components are the payload, which is usually at the nose cone, and the rocket and combustion system, which just burns the gas that you're using or fuel. So launching a rocket is really, really complicated. In order to achieve like a maximum efficiency when you're launching, the actual boosters of the rocket detach from the body so that there's no extra weight being projected once the rockets aren't needed anymore. Um, Once the astronauts are in place and the rocket is fueled, the launch pad and tower disconnect from the rocket, and then the boosters ignite and the rocket takes off. And after about a minute, the rocket has undergone the worst stress it will endure. In any space flight, it's usually about a minute to a minute and 20 seconds that most stress is done with, because then the atmosphere is getting a lot thinner. There's not as much friction on the rocket, and it's much easier for it to move at that point. So after that period of worst stress, the payload actually just detaches from the rest of the rocket and exits the nose cone, and it flies into space. And in SpaceX's case, it's really cool. They didn't want to waste those rockets, as probably no one would. So they made the rocket such that when they fall back to Earth, the boosters will reignite and slow it down. And then they have these drone ships that go out into the ocean, and the rockets land on the drone ship, and then they can use it again, which is really cool. Um, so another really interesting thing to think about is, why do astronauts feel weightless on the International Space Station? Over there on the right, there's a bunch of gobbledygook. But the idea is, a lot of people think they don't feel like they weigh a lot because they're far enough away from the Earth to not experience its gravitational pull. And if that were the case, why wouldn't the ISS just fly off into space rather than orbit the Earth? The astronauts are still very much being pulled by the Earth's gravity, but they're counteracting gravity with something called centrifugal acceleration. Centrifugal acceleration is kind of a like fake. It's not like it's like a perceived acceleration experienced by anything orbiting another object. In order for the ISS to maintain the same height above the Earth, it basically just needs to be traveling fast enough such that as it falls, the curve of its fall is like aligned with the curve of the Earth. So it kind of just perpetually falls around the Earth, but in outer space. So it's always falling towards the Earth, but it's falling around it. And that's what provides that weightless feeling.
Yeah, that's how
So
I
they're not
always
actually
describe
weightless.
it to my classes is orbiting is falling and missing the ground. That's it. Continuously
Hmm.
falling and missing the ground.
Yep. Yeah, exactly. So they do weigh the same. I mean, maybe like hundreds of a percent less because they're a little bit farther away from the surface of the Earth. But they do still get pulled by Earth's gravitational field. They just, like Jessica said, they're just missing the ground a lot. And once you get into a stable orbit, you miss the ground forever. Well, not forever, I shouldn't say that, because there's still a little bit of air up where the International Space Station is, and the friction between the air and the International Space Station slows it down, so it does fall down a little bit, but then it has little rockets that push it back up, and then it's good for a while. Um, so another thing I want to talk about is, what do astronauts do on the International Space Station? Astronauts usually stay on the ISS for about 6 months and can even go closer to 7.5 or 8. Um, and while on the International Space Station, the astronauts are effectively scientists doing experiments that can only be performed in space. The ISS is meant to be a laboratory where experiments that require microgravity can be carried out, and the astronauts are told by the scientists that designed the experiments how to do them. They also ensure that the ISS is functioning properly and staying safe for themselves. And in addition to this, they have to exercise daily, as the absence of gravity means that they don't really resist anything. So like the reason our legs are strong on Earth is because they're holding us up versus our gravity pulling us down. But when they're not experiencing that, when they're only experiencing weightlessness, you get something called muscular atrophy, which just means your muscles are dying pretty much. or they're not being trained continuously. So they had to design these like special workout machines out there that still do offer some resistance. You can see here on the right, it looks like an astronaut is doing like squats, but one of his knees is up, which sounds terrible. But yeah, there's a lot that the astronauts do out there. And just kind of like a little interesting note, as the International Space Station is a laboratory, the predecessor to the ISS, which I didn't even really know there was one until fairly recently. There was a predecessor, there was a space station before the ISS, and I believe it was called Skylab, I think. Jessica, maybe Lindsay, if you know, you could correct me, but I think it was called Skylab.
Yep, that's right.
So yeah, so it's a laboratory pretty much, a laboratory that the scientists also sleep and do squats in. So another really interesting thing is sleeping on the ISS. So we'll watch this really cool video of Chris Hadfield explaining how astronauts bunk on the ISS, and it's really cool. So let's start that video.
Hi, Chris Hadfield here aboard the International Space Station. We keep busy on board the space station. Long days, lots of work, physical exercise. At the end of it, you're tired. But how do you sleep in space? In order to make it comfortable for the astronauts, originally they were going to put us all in one habitation module with sleep stations all around it. But the way a station was eventually built, we have sleep stations inside Node 2, which is the forward part of the station, and inside the service module, which is in the aft. A total of 6 small bedroom sleep stations, sleep pods. And inside each one is just a sleeping bag tied to the wall. You might think it's uncomfortable not having a mattress and a pillow, but without gravity, of course, you don't need anything to hold you up. You can just completely relax. And you don't even need a pillow. In space, you don't even have to hold your head up. So you can relax every muscle in your body, and your arms float up in front of you. Your head tips forward. But before I go to sleep, I got to put on my pajamas because I have space jammies. I'll be right back. Great. I'm in my super comfy Russian full-length pajamas. Nice for when you have to get up in the middle of the night, and ready to go to bed. I'll show you where I sleep. This is my sleep station, my sleep pod. This is where I spend up to 8 hours every day here on board the space station. It's actually on the floor, but once you're inside, you just can't tell.
Okay. I don't know if anyone else is claustrophobic, but I sure am, and that also made me a little struggling to breathe. So again, maybe space isn't the right place for me. But
See, I feel like I had the opposite reaction watching this. I am, but like seeing him just zoom through the hallways and the thought of just being able to completely relax when you sleep. If I wasn't so terrified of the actual trip and being on a rocket, I kind of wish I could experience that.
it's something about the Harry Potter nature of that little closet that he slept in. Just I don't know, and also like the padding on the wall. It just I don't know, something about it made me a little, gave me shivers. But so now I want to talk about kind of recent events in spaceflight, specifically Crew Dragon stuff with SpaceX and NASA. So the latest in spaceflight news is obviously SpaceX's Crew and Cargo Dragon series of space pods, which have been designed to carry people and cargo to the International Space Station and even further, with future plans to use them to reach Earth's moon. Pictured here is Crew Dragon on its Demo 2 mission, where astronauts Bob Behnken and Doug Hurley journeyed to the ISS to prove that Crew Dragon was fit to house and deliver astronauts to outer space. This was, gosh, a year ago now. I think it was April of last year, if I remember correctly. So Crew Dragon has been being used for quite some time now. And after Demo 2 came Crew 1, which was the first operational flight of Crew Dragon to the International Space Station. This means that the astronauts on board stayed on the International Space Station for a prolonged period of time, whereas Bob Behnken and Doug Hurley, I believe, were up there for only like 2 months or something like that. And they conducted experiments while they were up there. So the purpose of the mission was not to test Crew Dragon. The purpose of the experiment was to, or the purpose of the flight was to get them up there so they could do more on the International Space Station. So during Crew 1, Crew Dragon was docked to the ISS for 165 days, which just destroyed the previous record of the longest flight by an American vehicle of 84 days, which I think is pretty cool.
So we
And this
got
is
a
the,
question that's kind of
oh, sure,
related to this.
sure.
So they said the docking procedure looks incredibly fine-tuned. Who controls the guidance systems? The ISS personnel, the astronauts in the nose cone, crews on Earth, or how much of it is computerized? Do you
I
know?
think that I've looked at some stuff like that. I think the best answer I could probably give is all of the above. Everyone's kind of coordinating it and working on it. Um, there is, believe it or not, there is actually a person in the pod steering it. And there's a little like Flash. Well, I guess Flash doesn't exist anymore, but there's a little game you can play online, and it kind of simulates what they're doing when they are steering the pod, getting it ready to dock, and it's really hard. Like it's insane. Like you flick your mouse like a centimeter, and you're flying towards Mars. Um,
Yeah,
there are people.
from my
What were you gonna say?
understanding, as much of it as that can be computerized is,
Right.
but there is someone in the nose cone or crew dragon or whatever system you're
Yeah.
in that does actually have manual controls to help make sure everything is perfectly aligned.
Yeah. I think probably the majority of it is math done by a computer that tells you if it launches from here and goes this fast, it'll be this close to the International Space Station. But when it really gets down to it, I don't think much of it happens on the ISS. I think if anything were to happen on the ISS, that control would probably be done by people on Earth. Like I don't think there's somebody controlling like the arm on the ISS. But yeah, there is work that these astronauts do. Like they do steer, and it's insane. I would be a nervous wreck. Um, but yeah, that's a really cool question. I'll see if I can find that little game and put it in the comment or in the like the chat thing because it's hard. Um, so this is the crew of Crew 1 who all returned earlier this month, actually. From left, we have Shannon Walker, Victor Glover, Michael S. Hopkins, and Soichi Noguchi, who's actually a JAXA astronaut, which is the Japanese Aerospace Exploration Agency, I think. And but he went along with Crew Dragon to the ISS, and they just got back earlier this month. Um, After Crew 1 was Crew 2, which was just another crewed spaceflight that carried 4 astronauts to the ISS, and that happened on April 23rd, 2021. And they're still up there. They're still conducting experiments on the ISS. And here's the crew of that. We've got from the left Kay Megan MacArthur, Tom. Okay, that astronaut is French, so I believe it would be pronounced Thomas Pesquet. Then another JAXA astronaut Akihiko Hoshide, and Shane Kimbrough or Kimbrough. So that's what Crew Dragon has been up to lately. What it's going to be up to, that image didn't come across very well, I'm sorry. But that's the mission patch for this upcoming mission. Further plans for Crew Dragon are the Inspiration 4 mission, which will carry 4 civilians to outer space and mark the beginning of space tourism, pretty much. After Inspiration 4, plans are being made by SpaceX to bring civilians to the moon. And even further. And when that does happen, it will probably happen in this spacecraft. This is Starship. which is another SpaceX invention. And it's in SpaceX's future plans for space tourism. And it's a fully reusable rocket-propelled spacecraft, which is actually made of pure steel. As you can see, it doesn't look like painted white like other things we see. This one's made of pure steel. And pure steel is a lot heavier than aluminum, a lot. And when Elon Musk was asked why he made this spaceship out of pure steel when he could have made it out of aluminum, and remember that process we were talking about back there where, the rocket's heavy, you got to add more gas, but now you've added more gas, so you need a bigger rocket. But now your rocket's bigger, so you need more gas. This process could have been simplified a lot by using aluminum because steel is just so heavy. But when he was asked why he did make it out of steel, he said because he thinks steel looks cooler. And I tend to agree. It does look pretty sweet, but that could have been a lot simpler. Also, Starship is still only in testing. I don't know what the number is, but a lot of them have blown up, a lot, and they cost millions each one. So that's some scratch that's gone down the drain there in these test flights.
But
But
15 did it.
oh, did it
Starship
really?
15 landed and did not blow up.
When was that?
Um, it was at the beginning of the month because I talked about it at the What's Up May show. It happened that day.
Oh, okay, that's
So if you
great. Well,
want
good news.
details on that, anyone, you can go back and watch that video. Because it was like an hour before we went live with that show. It happened.
So if it was number 15 that did it, that means that 14 did not do it. So that's 14 multi-million dollar spaceships that have literally blown up. Like you watch the video and they like hit the ground and they wobble funny and literally they explode like movie style explosion. It's kind of insane. But currently SpaceX is planning to use hopefully safer starships to bring large numbers of passengers between 2 points on Earth. That's kind of like the first step that they want to do with starships is rather than put these people in planes and use the atmosphere to get them from point A to point B. They want to put them in spaceships, skip the atmosphere, and then orbit the Earth and then come back down wherever those people need to go, which is awesome and the future pretty much. So with that, that's all I have. So I'm going to stop screen sharing. Close that window.
I don't know how I feel about taking a rocket instead of an airplane.
I don't like airplanes. I'm also scared of airplanes.
Yeah, I
Wow, I'm
am
really just
too.
digging into my fears. So,
Yeah,
but I think I'd rather take a rocket. Well, maybe not. Just
no,
that on it.
no, I am terrified of flying in planes, and I would rather take a plane than a rocket. I don't know. What do you guys think? Would you rather take an airplane or a rocket to get around?
You know how people clap when an airplane lands? I can only imagine what that would be like in a rocket ship.
Sighs of relief.
Yeah, pretty much, probably.
Just the
Yeah,
unclench the fists.
yeah, the seats are all mangled from people holding onto them.
Yeah, I'm not afraid of traveling in an airplane because I've done it a lot. Something about
I
that.
wasn't, and then I had a really bad flight, and I have been terrified ever since. Yeah, but someone said rocket or plane, no difference.
Yeah,
I don't know about that, but
hike it, like Sean Bean did.
all right. Well, I think we answered the question that we have, but if anyone has any other questions, now's a great time to leave them down in the comments. Um, I am kind of excited for the civilian mission. Like, that's
Yeah.
huge. Because this will be the first, right? I know that Crew 3 is scheduled to go up first.
Yeah. Yep.
And they should overlap with Crew 2, just like Crew 1 overlapped with Crew 2 for about a week.
Yep.
But after that, yeah, we've got the first full civilian,
Yeah.
which is kind of crazy that we are.
Do you guys know if they are undergoing the same sorts of training that astronauts do?
They're undergoing. I don't know if it's exactly the same, but they are going through leaps and bounds to prepare. And it should be mentioned, like, all of the civilians do have some type of experience with flight or something like that. Like one of the people is like an Air Force data analyst or something like that, and another one is a pilot. But like they're not astronaut. Like they were not hired by NASA to be astronauts. They are technically civilians. Um,
And they're
but
also like they're not going to the ISS, or like they're
no,
just gonna orbit the Earth like 3 times, I think,
yeah,
and
something
then
like
come
that.
back.
Which is a pretty quick trip. I don't know how long that is, but I mean, yeah. Well, what's the thing? How fast? How many times does the ISS come back?
I think the ISS makes it in. Why do I think
90,
90 minutes?
90 minutes.
Is it 90? Okay, yeah. So I mean, then they're gonna probably be a lot closer to the Earth than the ISS is. So it won't be too
Yeah,
long.
it will be. It'll probably just be a couple hours
Yeah,
up
but
there.
still, that'd be amazing. But yeah, I remember hearing like a year ago that SpaceX was like one of the first like big ambitions they had for Starship was to bring people to Saturn, like as like that form of tourism. But like that's like a 20-year
Yeah,
endeavor. And like the only thing I could think about is like, what if you went with like a girlfriend or something like that and like broke up?
that is a
Just
major commitment to make that trip. Oh my gosh.
like bigger than getting married because you have to be with them for 20 years.
Oh, all right. So I'm not seeing any more questions. But before we head off, I want to let everyone know what's coming up over the next week, because we're very excited since we are a week away from our astronomy day. But first up on Wednesday, we're going to do a show called Do Astronomy at Home, which is really looking at some of the tricks of the trade that astronomers use to study the universe, and going to give you a little bit of information about what you can expect in the toolkits we're giving out in Astronomy Day. So, like some of the science behind the activities we're going to give you, that you can come pick up from our Astronomy Day, and how you could use them at home to do, science yourself, be an astronomer from home. Then Saturday is Astronomy Day. So we will be set out outside the planetarium from 2 to 4 p.m. We've got these activity kits that we will be passing out for free. Each kit comes with 3 activities, that are made for all ages. So there's stuff that everyone can do. Um, we will also have a fourth activity that is optional to purchase on the side, and that is a DIY telescope kit, which we're kind of excited about. They're really cool. Um, and we'll have some demonstrations. We're raffling off a Lego Saturn V, just lots of fun stuff. You can find the link to the event in the video description. And then that night, we are doing a or a online component in place of our regular Saturday live stream. We'll be doing a 2-hour special Astronomy Day live stream, and we've got some great guests lined up. Bob King's going to join us. A member of the Arrowhead Astronomical Society will be with us. Jim Rock. Uh, Eli and Lindsay are going to talk a little bit about what it's like to do astronomy research, as a student and grad student. And we'll also just give you a little bit of update of what you can expect from the planetarium over the summer. We've got some exciting things that are coming up. But with that, let me check the comments again. I think we have covered everything. So we are really excited to be getting back out and seeing people. Really encouraged and hopeful with all of the vaccine efforts, and things could be heading back to normal. And as much as I think we have enjoyed doing these live streams, we may be wrapping those up in the next few months. We will see, but I can give more updates on the future plans of the planetarium next week at our Astronomy Day live stream. But we will leave it there. Thank you, everyone, so much for joining us. Go out, enjoy the rest of this beautiful weekend. We've had some amazing weather, but do put in some kind words to the weather gods that, next Saturday will be just as gorgeous. But we hope to see you again. Have a wonderful evening, and we'll see you next time. Bye, everyone.